And the topic for today is choosing the right LLM, right? And this topic is interesting because, every 2 or 3 months, newer models come with newer capabilities, and they all show their performance against standard benchmarks, right? There is MMLU, which is like a huge database of questions, and they show the performance improved in against that. Or there is something called a tau bench, which is for all the tools calling. Then there are different benchmarks, and they show like, look, my LLM from Anthropic or OpenAI, they're the top of the rank in terms of that specific tool, that specific database, and they publish that results, right? And there is this website called LM Arena where we can go and see the performance of LLMs against these standard benchmarks. But in enterprise, if you are in the business of building agents for enterprise, then you have a different problem, right? You need to choose a good LLM to match your application. And unfortunately, these benchmarks are not sufficient for you to choose the right LLM for your applications, right? You need to kind of think through in multiple ways as to which is the right LLM from your application standpoint, based on your performance requirements, based on your cost budgets, and based on your latency budgets, right? And today we will talk about a framework to choose the right LLM. We'll look at code for one of the use cases, and we will see how we can choose the right LLM. And then after that, we will go through some questions and answers, so to see if we can put that framework to practice. Okay, so that is going to be the plan for today. And we will see how long it takes. Hopefully, you will get value out of it. All right. So you're all familiar, I hope, that about this concept of agents, right? What is an AI agent? Just to level set everybody, in my world, it's a Gen AI based application that attempts to achieve a business goal or a goal by observing the world and acting upon it using the tools at its disposal, right? And it necessarily has a model which helps it make choices in terms of tool. It makes choices in terms of the planning and orchestration, and it makes choices in terms of using memory in clever ways, right? And the goal ultimately is to solve a user's request. So if you see here on the left, you have the user's request that hits the LLM model, and then the LLM model makes us probably like a plan, and then based on that plan, it hits some tools. Based on the information from the tools, or based on the information from memory, which comes into the context of the LLM model, the model then starts to answer the questions of the users, right? So I think it is fairly clear to everybody that this LLM model, which we make a choice of, is at the heart of an agent in many ways, right? You can put a lot of things around it, and you can empower this LLM model to do many things, but the brain of an agent is the LLM model, correct? And it does many tasks, right? It is involved in kind of breaking down the tasks, complex tasks, into smaller tasks. It's involved in iterating over the use of tools. It's involved in sensing using the tools. So it does a lot of things. Now, it becomes clear now that I need to make a good choice of this LLM if my application has to be performing well, right? Now, what are the parameters to think through, right? That is the next question which we need to ask ourselves, right? If I have an application, what are the parameters I need to think through? And where do I know what are the models which are available? So this is the second question, right? So I believe, there are hundreds and thousands of models now. and slowly becoming a commodity. LLM is becoming a commodity, where you are seeing a lot of these LLMs which are available, both open source, closed source, proprietary and open weight models. So I say that there are sea of models and there's a spectrum of capabilities across each of these models, right? So now there are many dimensions in which you can look at these LLM models, right? One is the dimension of the size of the model, right? And the second is the dimension of the architecture of models, right? Which type of architecture you want to choose. The third is a dimension of the cost of operating, right? And the fourth could be the modality which the model supports, right? Does it support speech, text, voice, or video, right? So these there are many such dimensions. So there is a spectrum or a plethora of capabilities, and there are hundreds of models, right? If you go to this Arena leaderboard today, I think at least when I made this slide, there were 234 models. Let's probably quickly see if I can go to LM Arena .ai and see what is there here, right? Um, let's go to the leaderboard here. Notice that I have so many models all over here, right? Categorized by function, like for text. There is this Gemini 3 Pro, Grok 4.1 Thinking, Gemini 3 Flash, and there's a score, there's votes from people in the last 7 days. Similarly, for coding, you have Claude Opus, GPT 5.2, Gemini 3 Pro, and so on and so forth, right? So there are lots and lots of models and for different functions, right? So let's spend a little time understanding what are the different functions which are here and before going back, right? So there is the models which are categorized and ranked based on text. Second, there are models which are ranked and categorized based on their coding capabilities because coding agents are very popular, right? On vision, on text to image, right? Image editing capabilities, multi-image editing capabilities, searching capabilities, text to video, right? And image to video. So each of these are capabilities, and then there is an overall ranking also, right? So if you see here, there are overall rankings, and let's see how many today we have, right? Like last time I saw there were 237, but today there is a lot more, right? There are about 300 and odd models, right? So there are 300, well, much more, I think, but the rest of them haven't received a vote here yet. So all of these are models which are available for you. And now, obviously, any person who is building an application is probably confused, which model do I use? And should I, if I think about building an agent, should I choose randomly one from here, wherever it is like NVIDIA Llama 3.3, or what's my thought process? So this is likely going to be a common question, right? So, as I told you, LLMs differ by size, cost, capability. And also, one important thing is, if you think about uh, the breakup of cost in terms of an agentic application versus a simple software application, right? Um, the LLM inference cost almost accounts for about 70 to 80% of the inference cost of the total application cost, right? So the LLMs are also the most expensive part of that software, right? Like the rest of the 10% maybe for your databases and then like including your cache and everything, and then about 5% for your networking capabilities and about 5% for your observability and all the bells and whistles you put around, right? So an agentic application necessarily is I mean, its cost is totally dependent on the cost of inference, which is the cost of using that LLM to get an answer, right? Um, so what are the design choices for the developers? One is, should I use an open source model? If so, why? or can I use a proprietary model, right? And what are the advantages and disadvantages? This is one design choice. Why? Because open source model probably gives me full control and a lot of privacy, and the proprietary models may give you a plug and play performance and a lot of inference server management is kind of abstracted away, right? It's managed service. The second thing is the size of the model, right? Like, do I need a large model for this? Or is a small model sufficient? Is the task, a general task or a smaller task? So, the trade-off is between higher accuracy versus faster and cheaper inference, right? Um, then from a model capability standpoint, do I need reasoning capabilities? Do I need multimodal capabilities? Do I need, tool calling capabilities? So these are different capabilities. From an architecture standpoint, again, as a designer, I need to think through, do I need an encoder only model, or do I need a decoder only model, or do I need an encoder decoder model based on the type of tasks, right? So these are all design choices which developers need to make at various stages in building an AI application. So I think I already covered as to why a model choice is mission critical. So there are a couple of reasons apart from cost, right? I already told you that 80% of your cost is your model inference. The second is, how do you interact with these models? You don't write code to interact with these models. You write prompts. Now, a prompt is usually optimized specifically for a given model and a given agent, right? Now, if I take out a model and put another model midway in my development process, then I need to really go back and re-optimize my prompts, right? So there's a lot of effort involved in getting the prompts right, getting your tool calling right, and getting your memory and other decisions right. And those decisions can be severely impacted the moment you change a model, right? So it's an upfront decision in your design process, and you need to really think through that. And if you make some silly errors there, then you'll probably end up having a lot more of development time in your application, right? Um, so by now you are probably clear that my point of view is that there is no one good model for any application. There is no one good model for all applications. The best thing that you can do is match a model's profile to your application's needs, and then create an agent which is effective, fast, scalable, and affordable. Right. So my point here is. There is no point in us being dogmatic that this is the best model, but we need to really look at, put a critical eyes on and say, okay, given my application, its needs for scale, cost, as well as speed, what is the need, what is the type of model I need, and can I get away with the cheapest possible model to do this? Okay. So right now, let us kind of see a quick demo, right? I have a demo here of code. This is for a case study, right? Like, so imagine there is a company which is an insurance provider, and they need to provide, process 50 to 60,000 claims monthly. So there's a lot of, uh, you know, queries which they get. And these queries can typically come as emails or any form of chat queries. So first question which we need to ask as designers and developers is this a good case for using agents at all, right? And here I believe the answer is yes. Why? Because there is a natural language interaction between the system and the user, right? And there is advantage in looking at the questions in free form, right? As opposed to doing a quick click and drop down from a front end, right? So if I kind of think about the user journey, then there is naturally a need for us to have an ability to parse natural language, right? And other aspects about this business problem is, there is a high volume of queries on any given day because a lot of people would be claiming claiming insurance, claim for their insurance. The queries are complex; they're not straightforward. Many a times, sometimes it may be a very straightforward query asking, what is my claim limits, and other times it could be a very complex queries. Now, decisions are time critical, right? Because people who are claiming insurance are already in distress. So you need to give them response quickly. You can't take forever. And from a business perspective, your accuracy is important, right? Like if you get a decision wrong, you probably spend money where you shouldn't from a business side. And if you get it wrong in the other way, then probably get sued because, the incorrect decision could lead to you basically not servicing a request which you're supposed to be serviced, right? So there's a human cost and there's a business and regulatory cost. Now let's think about, you know, how this is done in the world today. You have somebody who's managing these claims. He's going to look at multiple documents, and this knowledge is probably fragmented across different documents, across systems. So he's going to do SQL queries, collate it, and then come up with a perspective, and then he's going to, have a judgment on, whether an application or a claim has to be supported or not. So there's a lot of compliance pressures. There's a need for audit trails. There's a requirement for source citations and so on. So now this are all the parameters along which this application has to be developed, right? So now if I kind of think about this, right? Um, what type of an agent should I build for this, right? The type of agent which I would need to build to solve this type of a problem is probably what is called a RAG agent, or retrieval augmented generation agent. Let me quickly show you what that agent is, and then explain to you why it needs to be that, right? Uh, so retrieval augmented generation, basically there is three words there, right? Retrieval, augmenting, and generation, right? So imagine I hit a query, right? Like which says, I have had this hospitalization. I'm claiming a specific, amount of money to be dispersed to this hospital for my health insurance claims. So this is the query here, right? Now, what happens in a rack system is you take that query, you pass it through what is called an embedding model, right? And what you get out of this embedding model is a embedding for the query itself, right? So which is a vector. Vector for a query. You take that vector and hit a knowledge base, right? And the knowledge base could be a vector database. You hit that knowledge base and you retrieve some documents which are relevant for this query, right? Maybe I've I've had like a fracture, and I have an insurance from a specific company, and this query, so semantic meaning is going to be captured by the embedding. That embedding is going to hit the vector DB, and we are going to retrieve all documents related to fracture and also all documents related to me, the individual. And that is the retrieval part, right? So once I get these retrieved documents, then I pass that query as well as the retrieved documents. I'm going to augment it. I'm going to kind of club it together, right? And then pass it to an LLM. And this LLM is going to generate a result with this, final context. So now basically the query is, I have been hospitalized. I need you to process this claim. Probably the vector was created here after the embedding model. It goes to the knowledge base. I retrieve all the information. So then query plus that information goes to the LLM, and then the LLM reasons about it and generates a response saying that you're eligible for 2 lakhs in dispersals, and it will be dispersed by end of day. And then so that could be a generation, right? Um, So this is the application which I'm going to show you. Now the question is, this is the architecture which I have for the agent. What LLM will I choose? Okay. To make it simpler for our conversations, I'm going to make a choice across three combinations. Okay. The first one is where I'm going to pass this query with all of these bells and whistles to a Llama 8B instant model, and I'm going to get the results, right? This is one configuration. The second configuration which I'm going to run through is the same set of queries. I'm going to run through a Llama 70 billion parameter model and get some results, right? Now, obviously, this is a bigger model, is going to cost us more, uh, but I'm going to try these two configurations, run two experiments, right? And then the third one is where I'm going to send the query to a classifier, and I'm going to pass the simple queries through the Llama 8 billion parameter model. And I'm going to pass the more complex queries to Llama 7 billion, 70 billion parameter model. And I'm going to get the results. Okay, so these are the three configurations which we're going to test, and we're going to see how they perform one versus the other, right? So these are experiments, and if you're building agents, you should become very familiar with running these type of experiments. Okay, so let's look at that. Right. So in the first cell, what I'm going to do is just import certain packages, and I'm going to use these models from an inference service called Grok, GROQ, not related to Elon Musk. This is a company which is now acquired by NVIDIA. And they host a lot of models, and I can use it for free, right now for my testing purposes. So I'm going to use that. The next cell is where I am going to define these two models, right? Llama 3.1 8 billion instant and Llama 3.3 70 billion versatile. So these are the two models. One is a little, the parameters, we'll explain that later, but basically think of it as a size of the model for now. Um, Now, I have put in some pricing, approximate pricing for per million tokens. For the simple model, it's about 5 cents for input tokens and about 8 cents for output tokens. And for your 70 billion parameter model, it's about half a cent or 60 cents for input and about 80 cents for output for a million tokens. Right. So this is you could always spec it out with some different numbers. Let's quickly go and check that Grok service, right? So if I go here, Grok, um, so notice here 5 cents and 8 cents and 59 cents and 79 cents per million tokens. So these are numbers which are there, and there are a bunch of other models which are supported in this inference service, like GPT OSS 20 billion, Whisper, and all these guys, right? Um, so, if you are trying to build applications, this is one place you want to go and use these models for free, right? For at least testing purposes. Okay. So I have these two models and I have instantiated these models. Now what am I going to do? I'm going to look at my knowledge base. Okay. So the knowledge base for this is, there are different types of coverages. There is different types of insurances, health insurance plans, auto insurance. So it's, then you have claims processes, you have some required documentations. There are reasons for claim denials which could be selected, policy modifications. So there's a lot of these data which is insurance specific in these are the knowledge bases, right? So I'm going to take this knowledge base and this is like a fairly long knowledge base. Think about it equivalent of having a PDF file with all these details, right? Now, in real world, these PDFs can be fairly complex, right? How do I choose? How do I chunk these PDFs? How do I parse this PDF is a design choice and a task in itself. But for our, current problem, I've kind of put this knowledge base right here in front of you. Once I have this knowledge base, then I also need to kind of think through what are the questions which I can expect from the users for this agent, right? Now, I've classified that as, some simple queries. What's the monthly premium for gold health insurance plan? These are factual queries, right? Then there are some medium queries which require some reasoning. What documents do I need to file for an auto accident claim? So these are queries which are not necessarily just a lookup. There is some decisioning which needs to be made. So these are medium questions. Then there could be complex queries which require multiple hops or multiple document pieces. So if I have gold health plan and incur $15,000 in medical bills, exactly how much would I pay out of pocket? Show your calculations. Now, this is a much more complex queries. And then there could be queries which look across multiple sections of this document, right? And there could be some queries which are, very hard, right? What is the dental coverage limit? And this data is not there at all, right? In our knowledge base. And this agent has to be always grounded in the knowledge base. It can't kind of use its own brains, right? And and the way I have written it here is there's the query, there is the expected answer, there's a complexity type, then some key facts, and the query type, right? Is it a calculation type of query or is it a synthesis type of query and so on? Okay, so this is the set of queries. We now have the knowledge base. We have kind of identified which are the models. And now I need to kind of go and build this uh, RAG agent. Okay. So the RAG agent basically has this call LLM function, okay, where I define what is the system prompt, which says, you're an insurance expert assistant, and you're going to always go and look at the context and answer the question, right? So this is the system prompt, and the context is going to be specified here, okay? And we then have some time measurements and then to kind of look at the latency, right? So this is the one function. The second function is going to calculate the cost per query. Then the third function, evaluate response, is kind of a judge, which is going to evaluate the response that the LLM has given with the expected output. Okay, so this is what we're going to look at. And yeah, these are the core functions which are used. Okay. Then what next, right? I am going to define a classify query function, which is going to classify queries into, either simple, complex queries. And based on that, it is going to be a routing. This is for the configuration C. Just to kind of refresh your memory, it is the configuration C. Configuration A does not require a classifier. Configuration B does not require a classifier. Configuration C does require a classifier. So this is the configuration C's classifier function, right? Now the details of this, you could implement it in various ways. Here I've kind of used some heuristics to kind of classify. It could be an ML model, it could be another LLM, whatever it is, right? So right now I have a basic classifier. So the next step 6, is for me to run some experiments, right? So I'm going to define the 3 configurations and I'm going to run the experiments. Okay. So let's run all these 3 experiments for, config A, which is the simple model, config B, which is the better model, and config C is with the router and a combination. So now if I look at this, overall, how many queries did I have? I had Let me just scroll back up slowly, make sure I get that number right. So I had total of 27 queries, right? There were 8 simple queries, 4 medium queries, 15 complex queries with 6 queries which were kind of, which were out of scope or out of syllabus, right? So these are the 27 queries. And I'm going to run each of these 27 queries for all the combinations to kind of do this is my experiment. Okay. So I'm going to run it with config A, config B, and config C, right? So each query, and I'm going to run it, and I'm going to plot the latency. I'm going to look at its performance against my own evaluator, and I'm going to see the analysis of this results, right? So this is the experiment which I've done. And if I look at this results, right, config A gets an accuracy of 92.6%, right? So this is with the Llama uh, 8 billion parameter model, right? And it has an average latency of 5.8 seconds, right? 5,831 milliseconds, which is about 5.8 seconds. And the P95 latency, which is the 95th percentile of the latency for the queries, is about 9.8 seconds. So 95% of the queries take 9.8 seconds or less. And the cost for 1,000 queries is negligible, right? So it is 0.05 cents, $0.05, or 5 cents, 5.38 cents. But this can actually add up to some reasonable number if you know if you have 50,000 queries a day, right? So, but either which way. So this is the cost. This is the latencies. Now, if I use a better model, you know, notice here, right? The accuracy does go up, right? Accuracy does go up, and the average latency actually comes down. The better model is able to reason faster. It's probably going to use the tool much more efficiently. So actually, the average latency and the P95 latency falls down, and the cost actually goes significantly up. Where is 5 cents versus 62 cents for 1,000 queries, right? So it is significantly more expensive to run the 70 billion parameter model with for these queries. Now, if I kind of use the hybrid approach, which is the option C, the accuracy is actually the same. Notice this accuracy is same as config B. The latency is roughly in the same order, right? The P95 latency does go up a little once in a while, but the average latency is roughly in the same order. The cost is half of it. Why? Because I've kind of split the queries into complex and simple queries, and based on that, I've made some judgment calls, right? So here, the point I'm trying to make is it's not just the choice of the LLM, it's also the choice of the configuration and the architecture, which is going to impact your, your agentic applications overall cost. Okay. So there is some more breakup of the query complexity and how which type of queries the agent's performance was kind of different in, right? Like the simple queries, everybody performed well. Medium queries also everybody performed well. But for all the complex queries is where the difference started coming, right? Like and if your application has a lot more complex queries, then you would need a bigger model or you would need a configuration C. Okay, so this is the second thing. I can plot these for visual, the same numbers could be seen visually, right? So that's the details of this case. Okay. Um, so that was a case where we made a choice of an LLM among a couple of choices, right? I did not go and do a wide net, cast a wide net, and search. I made a choice across a few two LLMs at this point, but I wanted to give you a point of view of how to do that selection. Okay, so now let us zoom back out and let's think about a framework which can be used for you to down select from that 200 or 300 models in LM Arena to a few models which you can use to then, evaluate LLMs for your application, right? So you can't possibly do an experiment 200 models. You can do an experiment with about 4 or 5 models, correct? So how do you whittle it down from 200, 300 to 7? That is the framework which we're going to think about. Okay. So this is a 7-step framework. It is, in any enterprise, these frameworks are useful to ground the conversations. Otherwise everybody has an anecdotal reason to choose a model A versus model B. Better always to start with a framework which we all align on, and then those conversations could be more structured and meaningful, right? So what are the parts of this framework, right? First is the applications complexity, right? What is a core task which you're doing, right? Is it a simple QA or is it a multi-step complex question or reasoning? What is the likely type of questions which can come? That is the first question which you need to ask. And you need to t-shirt size the complexity of your application, right? The second pillar which you want to think through is the input and output modalities or types, right? Does your agent need to handle text, images, audio, or video? So have a sense for that, right? The third one is how much information are you going to put to the input of your LLM in this agentic application? So what is it that you're going to put in the context window? All right. The fourth capability is, how many tools do I have to use, right? Again, this is something where LLMs can make a mistake if the number of tools are many, right? How many external systems and APIs should the agent interact with, right? And what should be the capability of that LLM to choose the right tool, right? Then what are my speed requirements or latency requirements, right? And what is my budget for this application, right? And finally, what about some government or safety or regulatory guidelines? And across that, can I kind of look at different models, right? So the key questions which I would ask in terms of government and safety is, are there privacy requirements? Are there regulatory needs? Is it medically critical information? And do I have to kind of look at HIPAA guidelines, or is it, is the model, is the agent being operated in Europe, because of which there are data privacy laws and things like that. Okay, so this is a 7-step framework which you could use to select the right LLM. Okay. Now, obviously, if I give a 7-step framework and talk about it, you will nod your head and forget about it, right? So let's put this framework to action with some specific quizzes, right? So, now it's for you to be the judge, and to make it a little more meaningful and simpler, we are going to make a choice between these 5 models, right? GPT-4o, Gemini 1.5 Pro, Llama 370 billion, and Mistral, right? So these are the 1, 2, 3, 4, 5 models. And I'm going to give you different scenarios, and let us see which model would we choose. Okay. So that's the idea. So scenario 1, right? Imagine I have an e-commerce helper. So the application is, a European retailer wants order tracking chatbot deployed entirely on-prem due to strict GDPR and privacy regulations, right? And the chatbot integrates with internal systems and cannot use external APIs. So this is the requirement. Now, which model is a best fit across these 4? Let's see if you guys can type in chat. Which one would you choose, right? Let's get some conversation. Maybe if you guys can put your choice between A, B, and C, A, B, C, and D. Mr. Large, Gemini 1.5. Mr. Large, okay. Gemini 1.5 Pro. Again, think through the framework, right? Llama 3, 70 billion because deployed on-premise. Okay, lower size. Good, good. Okay. So I see some folks saying it has got to be Llama 370 billion, some saying Mr. Large, and a few saying Gemini and GPT-4o, right? Like, so this is different ideas, right? So the verdict, according to me, is going to be Llama 370 billion. Why? Because let's kind of look through the framework and justify it for ourselves, right? Let's think about the type of application here, right? What is the questions which we are going to ask or user is going to ask to this agent? He's going to ask order tracking information, right? Order tracking information is not a very complex task. It's more of a lookup if you think about it, right? Natural language, but it's a low complexity task, right? So complexity is low. IO type is typically text only, right? People are going to chat with the system. There's no video, there's no audio. The context window is likely going to be small, right? These are independent questions. There's unlikely requirement for too many multi-turn conversations, right? Tool use is moderate to low. I probably need to hit the APIs or DBs for getting the order information. And probably I need to hit one or two PDF files to understand the policies or understand the specifics of that order. Speed and latency is critical, right? I need a fast response here. So speed is critical. Scale, I mean, a lot of people can ask these questions, right? Like if it's order tracking in an e-commerce setup, you'll probably have a few tens of thousands or hundreds of thousands of users uh, wanting to know the status of their orders at various points in time. And this can be kind of always, it can go high during, peak seasons like Cyber Days, things like that. And we have, in the case itself, that strict GDPR compliance and the model must be deployed on-prem, right? So I can't choose Gemini, even if it is good, because I can't deploy it on-prem, right? So the conclusion is Llama 3, 70 billion parameters. It could have been Mistral 2, because that can also be self-hosted, right? But it's unlikely to be GPT-4o or Gemini, right? I hope you kind of got how to use the framework to whittle it down to some reasonable answer, right? There's no perfect answer, but at least you have explicitly called out your thinking process. Okay, let's take another scenario and let's work through that, right? Scenario two, AI research assistant for internal enterprise use, right? So here, let's look at the application. So you're a large enterprise who want to do internal research, okay, for employees and summarize papers. You're supposed to answer complex technical questions, browse internal documents. Uh, Unfortunately, these documents are big, so the need for context is fairly large, right? So which model is the best fit? Uh, let's see the guesses again. Okay, let's get answers. Mr. Large, okay. GPT-4o, Gemini 1.5 Pro, okay. So I think you guys are getting the hang of things right now, right? Mr. Large, okay. Gemini 1.4, it has been higher context window and the ability to handle complex questions. Good. So I think Prabhu's answer is nice, right? So the verdict here is Gemini 1.5 Pro, right? Why? Let's again look at the framework, right? The complexity of queries that this agent has to handle is high because it's a research-based assistant, right? People can ask it to do different types of research. So the diversity of queries is high. and the requirement for summarization and so on is high. IO type, these are long text documents, papers, research reports. This is the type of IO. Context window has to be very large. That's already specified in the case. It needs to have strong RAG capabilities. But beyond that, I don't know if it requires too much of tool calling capabilities, maybe some calculators, but not necessarily interact with too much, maybe a good search as a tool. Here, you're not really worried so much about latency or speed, right? What you care more is about accuracy, right? Latency is acceptable because it's what are you bouncing it against? You're bouncing it against a human researcher who would probably take like a couple of days to do a certain research, right? Scale and cost, the medium scale or lower scale. So premium price is justified for the value right here. I don't mind spending money because this is a high value, low volume agent. Um, Governance and safety, there's nothing specific here which is specified. Internal deployment or secure cloud, both of these are okay. Most of these models, inference services can give you some security because many companies today are using cloud, right? So I would say Gemini 1.5 Pro with massive context window and strong summarization capabilities would be an ideal choice for this type of a case. Okay. So this is scenario 2. Let's look at a couple more scenarios. So a support bot for a multilingual global marketplace that accepts voice messages, processes photos, replies in local language, needs real-time multimodal understanding. So which one would you choose here? Let's see. C. Yeah. Right. Yeah, some of them want Gemini 1.5 Pro, some are okay with GPT-4o, right? So yeah, I think now you're kind of looking through this, and here I've chosen C, but it could have been Gemini 1.5 Pro also, reasonable, right? But here, if you think about the application, there's multimodal support queries, right? And then the IO type is voice messages, product images, and multilingual text. Small to medium context window. Tool use is minimal. Latency is the requirement here, right? Real-time processing is essential. And global deployment is required because this is a multilingual global marketplace. And, as long as it's a robust API and uptime is high, there's nothing special in terms of governance or safety. So let us say GPT-4o is the right choice here, right? So this is scenario 3. Now let's look at a couple of more scenarios before we kind of summarize. But the idea is to get this framework really clear in your head, right? What if a developer-focused code assistant in a secure environment, like let's say a bank or something? Even today, recently, somebody was talking about Cloud Code, which can run with with the self-hosted model, right? Like especially for banks or critical businesses, right? So similarly here, the application is a secure code-based assistant deployed internally in a fintech company. It helps developers to code and gives code explanation, helps refactor, give unit tests, but the code definitely can't be sent out, right? So which model would you choose? Uh, Automatically, you can throw out B and C, right? Gemini 1.5 Pro and GPT-4o. Llama 370B versus Mistral is where I have to kind of play with. And if you think about Mistral, it's a mixture of experts model. So this would be something which can handle these coding type of questions, diverse questions. So I would choose this, right? Among the available choices, I would use Mr. Large. The framework justification is the complexity of the queries are going to be medium to high. IO types are going to be text, basically code snippets. Context window is going to be medium. Tool use is basic with retrieval and on-prem databases. And typically you need reasonable latency, right? For iterations. Scale is low, right? And we have a requirement that the code can't leave the company's premises. So it has to be self-hosted, right? Okay. Scenario 5, I want a personal finance agent for India where people are going to ask questions in English, right? Things like Meri EMI kab hai and things like that. It's a mix of English and Hindi. The assistant must be something which converses fluently in Hindi, understands code, understands different dialects, and supports voice to text. So, which would be a good fit here. Um, Now, automatically, you can say Llama 370B is out, Mistral is out. It has to be between Gemini 1.5 Pro and GPT-4o, right? So if I had to choose between these two, I would go with Gemini 1.5 because it has much better multilingual capabilities, especially with Indian languages, right? Um, Now, if you think about the framework again, conversational agent in Hindi plus English with finance specific logic, right? And the IO type is voice to text and mixed queries. And then context window is small to medium. Tool use is light. Speed and latency is high, right? My mobile app has to be responsive. The scale and cost, the high reach in mobile apps means that, the cost can grow up very quickly. So you really need to be careful about cost here, right? And from a governance and safety perspective, as long as you can protect the user PII and there is a mobile friendly compliance, you can use any model, right? So the choice could be Gemini 1.5 Pro, right? So this is us just walking through 5 scenarios to choose models. Now, any application is going to be different, but the framework itself is reasonable enough for you to justify a choice of a model, and then based on that, maybe you have candidate sets of 4 or 5 models with which you can do experiments. Okay, so that was the whole idea, right? Take a summary of all the cases which we saw, right? And scenarios. So for on-prem e-commerce assistants, I chose Llama. For internal research, Gemini 1.5 Pro. Multimodal GPT-4o, Mistral Large for secure coding assistant, and for Hindi personal finance, Gemini 1.5 Pro, right? So this is a summary. And the key takeaways for you is, there's no single best model. There's only a right model for your specific application. Use a structured framework to evaluate and communicate across organizational boundaries about how to choose a model. And the frontier is always moving, right? So the best model for a task today might be a different one in 6 months, but so stay informed and choose LLMs wisely so that, your development cycle is a little more systematic, right? So you can choose effective and efficient agents which provide real business value to your users.